We're starting Unit 2 today of Functions, Rate of Change. On to Lesson 2.1, Determining Average Rate of Change. Once again, I'll start out by the definition. The average rate of change is the slope between 2 points. It is calculated by the change in the dependent variable, which is delta y, divided by the change in the independent variable, which is delta x. Delta y equals to y2 minus y1, and delta x equals to x2 minus x1. The definition of a magnitude is the absolute value of a quantity. And the secant line is a line that passes through 2 points on the graph of a relation. On the graph, the average rate of change is equal to the secant line. Let's look at example 1 from your learning resources. Find the slope or average rate of change of the following. Here we're represented with a nice graph, and let's ignore the blue line for a second and just focus on the red line, because the red line is our actual graph, is our actual function. There's one point here and another point here. The first point we labeled it x and f of x. The second point we labeled it x plus h and f of x plus h. The average rate of change will equal to delta y divided by delta x, which will equal to fx plus h minus f of x divided by x plus h minus x. That'll give us h. Note that this blue line on the graph is the secant line, and it shows the average rate of change. Now let's look at example 2 from your learning resources. Max was filling up a tank at 2,500 liters aquarium with water. He started at 1 p.m. and the tank was filled at 10 p.m. The following is a table of values of how filled the aquarium was every 2 hours. We're asked to find the average rate constant between 2 p.m. and 6 p.m. Start by writing out our original equation. Our delta y would be f of 6
minus f of 2, and our delta x would be 6 minus 2. Next, we look back at the table of values, and we see that at 6, f of 6 is equal to 1,500, and at 2, f of 2 is equal to 0. So we use 1,500 minus 0, that will give us 1,500, divided by 4, because 6 minus 2 equals to 4. Now, final answer will be 375. Thus, the average rate is 375 liters per 2 hours. So did the speed increase or decrease? Right now, we can't yet answer this question. That's why we have question B. Find the average rate constant between 6 p.m. to 8 p.m. We do the same thing as the previous question. F of 8, and we will have to look at that from our table values. F of 8 equals to 2,000 and f of 4 equals to 8,000. So 2,000 minus 8,000 will give us 12,000. Divided by 8 minus 4, that would be 4. And our final answer will be 300. Thus, the average rate was 300 liters per 2 hours. And in comparison to the last one, it was 375 before, but now it's 300. So the speed had decreased. So this is the end of this first lecture on Unit 2. Please do your practice questions as well as your assignments, and I'll see you guys next lecture.